Alright, so in my last video, we learned how to evaluate the derivative of power functions of the variable of differentiation using the formula method. We stated that the dk of k to the n is equals to n multiplied by what? K to the n minus 1. Do you get? You just use the power to multiply the expression, then you subtract 1 from the power. So that's basically the formula method. So a quick example, the x of 1 over cubic root of x will just be what? You know that this guy has to take the form of what? X to the n first before we can apply this formula, right? So this will be the same thing as the dx of what? X to the minus 1 over 3, right? Because cubic root of x is x to the 1 over 3, and 1 over x to the 1 over 3 is what? X to the negative 1 over 3. Do you get? Now let's what? Evaluate the derivative of this guy. So the power here is what? Minus 1 over 3. So that's minus 1 over 3 multiplied by x to the what? Minus 1 over 3 minus 1, right? So this will be equivalent to minus 1 over 3 x to the minus 1 over 3 minus 1 is what? Minus 4 over 3. And this will be what? Minus 1 over 3 x to the what? 4 over 3. And this will be what? Minus 1 over 3 cubic root of x to the 4. X to the 4 over 3 will be what? Cubic root of x to the 4. How? Because a to the m over n is equals to the nth root of a to the m. Have you got that? Now there is an important thing to take notes about this formula method. This formula method works only and only if n is a constant. That is, only if n is independent of our variable of differentiation. What I'm trying to say is that what? Suppose y is equals to what? X to the x. You can't say dy dx is equals to what? What is the power? The power here is what? X, right? This x in green. The power here is x in green, right? It's not equals to power multiplied by the x, which is the base. X to the what? Minus 1. Sorry, x to the x minus 1 rather. Do you get? I don't know if you get what I'm trying to say. You know, according to this formula method, d dx of x to the n is what? N times x to the n minus 1. But if y is equals to x to the x, dy dx is not equals to what? This x multiplied by what? This x to the x minus 1. This is not what? This is very wrong. I hope you got that. Why? Because this formula is only true as long as what? N is not a function of our variable of differentiation. I hope you got that. So likewise, the what? The dk of what? Of k to the cos k is not equal to what? Cos k times k to the cos k minus 1. Please, it is a very important truth, because it was happened to me while I was in college that this question was written on the board. I was just like, this is easy. Then I just used x to multiply the stuff and removed 1 from it, because I was not warned that this power must not be a function of the variable of differentiation. So we also learned that the derivative of a constant is 0. A constant is a function that is independent of the what? Of the differential variable. You can call it an expression also. So where c here is a constant, do you get? The dx of c is 0. So we already proved the fact that all numbers are constants. Now let me give you an example. The ddx, the derivative with respect to x of u cos inverse of u squared plus 1 will actually be what? 0. Suppose what? U is not a function of x. So if u is not a function of x, that means u is a constant. Cos inverse of u squared plus 1 is a constant, and the product of these two is also a constant. I hope you get what I'm trying to say. So it is not something that is actually far-fetched. I hope you get what I'm trying to say. So that is just how it is. The derivative of a what? Of a constant will always be 0. Right. So let's evaluate the d dv of what? V to the pi. You can try this out. the dv of what? V to the pi. So what will we do? You can try it. So yeah, let me do it now. So this is just be what, you know, we are just changing what? The variable of differentiation. It will still be this guy is taking the form of v to the n, and that will be n times v to the n minus 1. So n here is what? Pi. Pi is just a number, you get, an irrational number. So we just what? Use it to multiply. It's still a constant, so the formula still holds. So that's just pi times v to the pi minus 1. As easy as that. What about the ds of s to the cos e? E is Euler's constant. Our natural log, I think, is about what, 2 point something, or is that it? I can't really remember. But this guy is equal to what? The derivative of this guy with respect to s. Know that e is actually this Euler's constant, like the natural logarithm. I think it's 2 point something. So yeah. So that means cos of it is actually a constant too. So the derivative of this guy will still be applying the formula method. That will be the power, which is what? Cos e multiplied by s to the what? Cos e minus 1. So that's just how it is. Alright, so now let's move to another aspect. The other time I said what? The ddx of what? Of c or k times f of x is equals to what? K times f prime of x. What does this mean? It means the derivative of a constant multiplied by a function of x is equals to that constant multiplied by the derivative of the function of x. Like the ddx of k times f of x is equals to this k times the derivative of this real function. So now let me give you an example. The ddk of what? Of cos pi times k cube will just be what? Cos pi times the derivative of what? The ddk of what? Of k cube. I get what I'm trying to say. So that is basically what this law is saying. Please take it as important, because many people don't understand the basis of this stuff. So like evaluating the derivative of this guy, this will just be what? Cos pi multiplied by what? Differentiate this guy, that's 3k to the what? 3 minus 1, which is 2, which will now be what? 3 cos pi times k square. Or let's put it like this, that's 3k square cos pi. Sure you get. Yeah, it's better to put it this way to avoid confusion. I hope you got that. So yeah, let's take another one. The what? The dds of ln 5 cube over what? Over root s will just be equals to what? Will just be this ln 5 cube multiplied by the what? The dds of what? Of 1 over root s. Do you get? So that is basically what this law is actually saying. The real function here is what? Root 5. The constant here is what? Ln 5 all to the 3. Do you get? So you just what? This will just be equals to ln 5 all to the 3 multiplied by the derivative of 1 over root s. Sure you get? So that's basically it. That's basically what this law is saying. And evaluating the derivative of this guy, this will just be what? Ln 5 cube multiplied by, this is the same thing as what? S to the minus 1 over 2. So that will just be minus 1 over 2 times s to the minus 1 over 2 minus 1. The derivative of what? The derivative of what? Of s to the n is equals to n times s to the n minus 1. So the what? The power here is what? Minus 1 over 2. So I just what? Replaced. And I arrived at this. Follow me. This will just be what? Ln 5 all to the 3. Sorry, minus 1 over 2. Let's bring the minus 1 over 2 here. Then let's bring this guy down. That's 1 over s to the 3 over 2, right? Why? Because minus 1 over 2 minus 1 is minus 3 over 2. Bring it down. That will be 1 over what? S to the what? 3 over 2. Do you get? So this just be what? Minus ln 5 to the what? To the 3. Or to the 3 rather. Over what? Over 2 square root of what? S to the 3. So that is basically what our answer would be. Right, so now let's move to another wonderful part. So suppose y is equals to what? F of x plus or minus g of x plus or minus dot plus or minus what? H of x. What does this mean? When you have sum of what? Or difference of functions of your differential variable. The derivative of this function, like if your function is the sum or difference of functions of your differential variable, your derivative dy dx with respect to x will just be the sum or difference of the individual derivatives of this function. So that will be equals to f prime of x plus or minus g prime of x plus or minus dot 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 plus or minus h prime of x. What does this dot dot means? That means there are actually some functions in between. You get? So it doesn't mean when you have sum of two functions or difference of two functions or three functions, 5 functions, 7 functions, 100 functions. So that is why this dot dot is actually here. I hope you got that. So now let's take some examples under this. All right, so if s is equals to what? 5t to the what? To the 3 minus 2t square plus 4t minus 9. Find ds dt. So this is exactly what I'm talking about. You can see we have sums or difference of several functions of t. You get, we have 5t cubed, we have 2t square, we have 4t, and we have 9. Yeah, 9 is also a function of t, only that it is actually independent of t. Like it's form of a constant. Sure, you get, like constants are functions of all variables. I hope you get what I'm trying to say. Yeah. So yeah, ds dt will just be what? ds dt will be equals to, now you differentiate this guy firstly, 5t cubed. So don't forget our rule that d dx of what? Okay, we are dealing with t here. d dt of k times f of t will be equals to k times f prime of t, right? Exactly. So now 5 is a constant. We are multiplying a constant with the real stuff. So we'll take the constant out first. 5 times, now you find the derivative of t cubed. That's what? 3t squared. That's 3 times t to the power of 3 minus 1. 3 minus 1 is 2. That's 3t squared minus 2 times the derivative of t squared is what? 2t to the 2 minus 1, right? And that's what? 1. T to the 1, which is t, plus 4 times derivative of t is what? 1 actually, minus 0. The derivative of 9 is 0. Do you get? So this is just be what? 15t squared minus 5 times 3 is 15. You get, minus 2 times 2 is 4t plus 4. So this is the derivative of s with respect to t. 15t squared minus 4t plus 4. Let's take another example. Suppose y is equals to what? X squared minus 1 all of square over x cubed. Find what? Dy dx. Now you agree with me that this is not actually quite looking like this. So how do we go about it? All right, so follow me. The first stuff to do is to actually expand this bracket, s squared minus 1 all of square. You know, since it is just the power of 2, we can just expand it. So this is x squared minus 1 all of square. That's the same thing as x squared minus 1, x squared minus 1. So you open the bracket, you have x to the 4 minus 2x squared plus 1. How did I get this? You do this times this, then this times this, then this times this, and this times this. Then you get this after the whole evaluation. So this x to the 4 minus 2x squared plus 1 over x cubed. Next thing to do is that we express what? X cubed as the individual denominator of the expression or the terms in the numerator. So this is just be x to the 4 over x cubed minus 2x to the 2 over x cubed plus 1 over x cubed. Have you got that? Yeah. So this will be equal to what? X to the 4 over x to the 3. So what? To simplify this, we are just going to be applying the law of indices. We state that what? A to the m over a to the n is equals to a to the m minus n. I hope we got that. Yeah. So let's continue. So yeah, x to the 4 over x to the 3. That's x to the 4 minus 3. 4 minus 3 is what? 1. That's x to the 1, which is x. Follow me. Minus 2. X squared over x cubed. That's x to the 2 minus 3. 2 minus 3 is what? Minus 1. Plus 1 over what? X cubed. That's what? X to the minus 3 using the reciprocal law of indices. 1 over what? X to the n is x to the minus n. Now we can what? Differentiate. We cannot differentiate. The y dx. Once you start what differentiating, you write that is equals to the derivative of x is what? 1. Note that the derivative of x with respect to x is 1. The derivative of t with respect to t is t. The derivative of k with respect to k is what? Sorry, the derivative of t with respect to t is 1. The derivative of k with respect to k is also 1. And this thing actually is kind of, should I say, simple. Actually, we said d dt of t. That's the same thing as what? Dt over dt actually. And this cancels one another and this gives us 1. This is just another way of proving that what? The derivative of t with respect to t is actually 1. If we also say that what? The dk of k is 1. That's because the k cancels the k. I hope you get. That's just another way of proving that the dk of k is 1. I hope you got that. So now back to our original question. So yeah, we have minus 2. Then you differentiate the real guy. Use the power to multiply it minus 1 x to the what? Minus 1, right? This minus 1. Then you now subtract another one according to our formula. So minus 1 is what? Minus 2. Plus, the power here is what? Minus 3, right? Multiply by x to the minus 3 minus 1, right? Follow me. This will now be 1. Minus times minus is plus. 2 times 2 is what? 2 times 1 is what? 2, rather. X to the what? Minus 2. Plus times minus is what? Minus 3. X to the minus 4. And this will be what? 1 plus 2 over x squared minus 3 over x to the 4. This will be our final answer. 1 plus 2 times x to the minus 2, which is the same thing as 1 over x to the 2. You get? Using the what? The law of what? Negative. The negative index law, which states that what? X to the negative n is equals to 1 over what? X to the n. I got that. So that is just how it is. Stay with me. Let's take another example. If x is equals to what? Root theta into what? Cos inverse of u minus what? Minus theta. Find the x, the theta, where u is not a function of x. You know, they have told us that what? U is not a function of x, right? That means this cos inverse of u is actually a constant. But due to this minus theta that is inside, we actually have to use root theta to open the brackets. Are you with me? Stay with me. Opening the brackets, this will just be what? X will be root theta cos inverse of u minus root theta times theta is what? Theta to the 3 over 2. Stay with me. Be equals to what? Root theta is the same thing as theta to the half cos inverse of u minus theta to the 3 over 2. You get? We are told to find the x, the theta. I hope you get. So we have been told that u is not a function of theta. That means u is a constant. And that also means that cos inverse of u is actually a constant. Sure you get now. So what will be the x, the theta? The x, the theta will just be what? Now don't forget our rule. Cos inverse of u is here is a constant. But theta to the half here is actually a function that we have to differentiate with respect to theta. So that will just be what? Cos inverse of u times. Now the derivative of what? Theta to the half is what? 1 over 2 theta to the half minus 1, which is minus half, minus the derivative of theta to the 3 over 2 is what? 3 over 2 theta to the what? Theta to the 3 over 2 minus 1, which is half. Follow me. So this will just be what? Cos inverse of u over 2 root theta minus 3 over 2 root theta. Theta to the half is what? Root theta. I hope you got that. So yeah, don't forget the ddx of what? Of x to the n is what? N times x to the n minus 1. The derivative of a constant is always 0. The ddx of k times f of x is equals to what? K times f prime of x, which is the derivative of f of x. Also, the derivative of a sum or difference is the sum or difference of the derivative of those functions. I hope you got that. So see you guys in the next video.